Hello guys, welcome to the mechanic. I'm so glad to have you here once again. As you can see, this is not a normal venue, it's not a normal venue, but we have to be here because some persons are using the class we used to use. So for us to skip this day, I just say let's do something real quick. So now um I want us to look at simple harmonic motion. At the end of the lesson, I expect us to know what simple harmonic motion is, why it occurs, and the conditions for it to occur, and solve some related problems. So now, what do you understand by simple harmonic motion? Okay, simple harmonic motion is a special type of oscillatory motion in which the restoring force or the restoring acceleration is directly proportional to the displacement from the equilibrium position, which acts towards the direction of the equilibrium. Mathematically, we have the restoring force to be minus kx, where the k is constant and x is the displacement, right? So now, the reason why it's having negative sign is that it is directed towards the equilibrium, okay? So now let's look at the conditions for it to happen. For a motion to be a simple harmonic motion, first, there must be a restoring force. Secondly, the restoring force must act. Third, there must be an equilibrium, okay? And the object must be displaced from the equilibrium. If, for example, now let's use this simple pendulum box, okay? See, it must be displaced from the equilibrium, and it will come back to its position, right? So there must be an equilibrium, and the object must be displaced from the equilibrium, and the restoring force must be directly proportional to displacement. It must be directly proportional to displacement, and also the restoring force must act towards the equilibrium position. Do you understand that? So now we have some terminologies in this topic. We have equilibrium position, we have frequency, we have period, we have angular frequency, we have velocity, acceleration, energy. Yes, we have all that. So now we're going to briefly look at them and then solve some related problems, and we are done for today. So now let's first look at equilibrium position. What do you understand by equilibrium position? You know that equilibrium position is a position where the resultant force is what? Zero. What do you understand by resultant force? Is that single vector that have effect on both magnitude and direction, right? So now we see that single force at that point, it has no it is zero. You don't have any effect at that point. So that is equilibrium position. So now, what do you understand by angular frequency? If we're talking about angular, we know that this thing is a complete oscillation, like it's a circle, right? So now when we're talking about frequency, we know that it's the number of oscillation per second. So now, for a complete oscillation, we know that it's 2 pi radian, right? 2 pi radian for complete oscillation. So now, if it's talking about frequency, you know that it's a number of oscillation per second times the number of the complete oscillation, right? It will give you the angular frequency. So now it is given by the formula 2 pi f, where 2 pi represent the complete oscillation and frequency, the number of oscillation per second. So now we know that this frequency is also given as 1 over t, which is the inverse of period, right? So now when you substitute the formula of frequency in this angular frequencies formula, we have 2 pi over t, right? So that is the formula for it. So now we're going to briefly look at the displacement. You know that displacement change in distance, yes, displacement. So now this formula, we have this the formula for calculating displacement in SHM, as simple harmonic motion. It is given by a sine bracket angular frequency represented by omega t plus phi close bracket, and it also have a cos open bracket bracket angular frequency t plus phi, where the first one is a distance. It's a formula used in calculating the displacement from, let's say, from an equilibrium. When an object is at equilibrium, is displaced at equilibrium, you use the first formula. And the second one, if the object is displaced from the extreme, not from the equilibrium, from the extreme, like from the extreme, you use the second equation. Hope you understand. When we take some examples, we will understand very well. So now let's take few examples on this. We continue when we are in the class. I just want us to have the introductory part of it, because standing here doing the video is not really nice. So let's take few examples. Number one, we have a particle performs simple harmonic motion with an amplitude of 0.2 meter. Right? Are you there? 0.2 meter and a frequency of 5 Hz. That's just it. So number one, they ask us to calculate the time. 2, calculate the frequency. Right? They give us amplitude, they give us frequency in the questions. And the question is that we should calculate the time and the frequency. So which formula are we going to use? First, let's deduce the dimensions. We have what frequency? We have the amplitude in the question. What's the amplitude? The maximum displacement, right? They give us the maximum displacement. So now, how are we going to do it? How are we going to do it? Which formula are we going to use? Among the formulas I said, we have frequency there, and they ask us to find the time and the angular frequency. So we all know that if you want to calculate period, you take the inverse of frequency. If you want to calculate frequency, you take the inverse of period, right? So now they give us frequency, and they ask us to find period. Take the inverse of our frequency, and we have our answer. The frequency in the question, it was 5 Hz, right? So 1/5, we have 0.2, right? Second, because that's us to find time. So that's for the first part. The second one asks us to find the angular frequency. So now, which they give us a frequency. They ask us to find angular frequency, and we have frequency already. So substitute the value of frequency in the question, 2 pi f. You have the value of pi, you know it, times it by 2, you get your answer. 2 pi f, where our f in the question was 5. So now we are having something 2 times 3.142 times 5. Okay? So now we have something, it's 1 point something. So now, your turn, you solve this one. A body oscillates with a frequency of 10 Hz. Calculate its period. Calculate its period. And write your answer in the comment section if you get it right. Let me see who get it right. Oh, thank you so much for your time. Thank you for watching. Please, if this is your first time seeing our video, we are the mechanic. We are on the journey. So we are on the mechanic journey. We are just starting. I would love to see you in our next video. So if you don't mind, just follow our journey as we walk through the journey of the mechanic together. I'm going to continue next week Monday, and I would love to see you then. See you in my next video. Please don't forget to like, comment, and share the video. Or you want to be the only person seeing it, share it. Let's share the video. Like, comment your answer. Don't forget to solve it. Solve it and write the answer in the comment section. See you in my next video. Bye.